Hi all. Now we shall discuss about the failure of bolted joints. What do you mean by failure? What is the function of bolted joint? To join two members. If such joined members are separated without your intention, what does it mean? It is nothing but failure. If the bolted joint is broken, then it is failure. Here in machine design, you are going to design a bolted joint. That means you are going to determine the safe dimensions of the bolted joint. Safe dimensions in the sense they have to withstand the forces or stresses which may develop during its functioning. If they are unable to withstand the stresses, obviously they will fail. So when you are designing a bolted joint, first of all we must have the knowledge of different modes of failure. If you have the knowledge of different modes of failure, then only you can decide the dimensions according to that. Is it right or not? If you have the knowledge of how this bolted joint failure, then we will try to prevent that failure by adjusting the dimensions. A smaller diameter will fail. We know that. So in order to prevent that failure, we will use a large diameter. So in such a way, if you know the type of failure, then we can adjust the dimensions accordingly. So a bolted joint may fail in three different ways. The first one is tearing across the root of the screw threads. What do you mean by tearing? Tearing. If you tear a paper, it will be separated into two pieces. Similarly, a bolt may be teared into two pieces. So this is possible when a bolt or a nut is subjected to tensile load. Which type of load? Tensile. Yes, say, let me take this example. So this is a bolt. So I am representing the screws like this. Okay. So this is a bolt. Now this bolt is subjected to, or otherwise I will represent threads in this fashion. Okay, so this is a bolt. Now let us apply some tensile force on it. Then what will happen? When the tensile force is applied, the more amount of stress is developed at minimum cross section area. So this is what we have learnt in strength of material. When the cross section area is minimum, the stress is more. So sigma is equal to P by A. When this cross section area is reduced, when it is minimum, the stress will be more. When the stress is more, the element may fail. So that's why here in this case, can you tell me where is the minimum area, minimum cross sectional area? If you see this in the side view, this is the major diameter and this will be the minor diameter or core diameter. That means, see here this is the major diameter area, okay, which is represented by D, and here this is the minor diameter area which is represented by DC. So at the roots the area is minimum. So that's why when it is subjected to tensile load, this bolt may fail at the roots as the area is minimum. So here the failing means it may be teared. So it is separated into two pieces. So the bolt may be teared at the roots. So this is one type of failure which may occur due to tensile load. Okay, then how do you calculate this tensile stress, we have the formula, same. See, P is equal to, stress, sigma T is equal to load by area. So, if you want area is equal to load by tensile stress. Area, we know that it is pi by 4, this area. Pi by 4, is it DC square or D square? DC square, because the failure occurs at the core. So DC is the core diameter or minimum diameter. At that point we have minimum cross sectional area. DC square is equal to load is represented with P. So P by sigma T. Now by using this formula, you can determine the value of DC, core diameter. Do you get it point? Once if you get the core diameter, then you can find the nominal diameter also by using this formula. So we have this relation, DC is equal to 0.84 D, where DC is the core diameter and this D is the nominal diameter or major diameter. So this relation is used generally to calculate the core diameter or the nominal diameter when the other is given. Is it clear? This is an empirical relation. So with this you are getting the value of the core diameter by using this strength criteria, and then with this you can find out D value. So D is equal to DC by 0.8 D. Like that you can find it out. So we have to find out the major diameter only finally, because the screw threads can be specified by the major diameter only, not minor diameter. So this is one type of failure because of the tensile load. Now the second one, stripping of screw thread in the nut. So you have taken a nut and you are tightening a bolt into it. So at that time, see, thread is nothing but a helical groove which is cut over it. So in such cases, some part of thread may be separated out of it, just like a peeling. If you wind a rope over it, that is a thread, and if you remove it, it will be like this, that rope can be separated. In the same way, this thread also can be separated. So it is also a type of failure. If the thread is separated, the thread can be separated at this crust portion. So if it is separated, once again it is a failure. Even though the joint is not broken, even though the bolt is not broken, if the thread is failed, then they are easily separated. If you want to separate a bolt and nut, you have to unscrew it. But if there is no thread, simply you can remove it. So that's why this is also a type of failure which may occur in this. So in order to prevent this, we must increase the shear strength. So every bolt will have both shear strength and tensile strength. Shear strength is the maximum ability of the material which can resist the shear load. Tensile strength is under tensile load. So if you can make the shear strength is equal to tensile strength, then this type of failure can be eliminated. If shear strength is less than tensile stress, this type of failure may occur. Or simply if the shear stress developed is less than tensile stress, this type of failure may occur. But if both are equal, then this type of failure can be eliminated. So this is the second type of failure. And now coming on to the third type, direct shearing of the bolt. So this is also due to the external loading, especially when two members are joined and they are subjected to shear load. See, for example, these are the two members joined, to be joined, so they have being joined by using this joint. So that is the bolt, okay, and this is the nut. Now assume that this is subjected to a loading like this. Now which type of load is this? This is a shear load. So due to this, the bolt may shear at this point. So half of the portion will come in this direction and the remaining half will go in this direction. So that is nothing but shearing. Okay. So due to shearing or due to shearing load also, the bolt may fail. So this is another type of failure. Then how do you calculate the shear load? Once again we have the same formula. So shear stress is equal to P by A. Shear stress is equal to P by A. Now if you want A, it is P by tau. A, once again it is the cross sectional area. It is the cross sectional area. So what is the formula for cross sectional area? Pi by 4 d square is equal to P by rho. Observe that here we use nominal diameter, not core diameter. In case of tensile load, we are using core diameter, which may cause tearing across the roots. Because it is tearing across the roots, that's why we are using root diameter. But in this case, in case of direct shear, we are going to use the diameter, that is the major diameter or nominal diameter only. So if you get the value of nominal diameter, you can easily find out the core diameter by using this value if you need it. Okay. So here D is nominal diameter and this tau is shear stress and this is shear load. Okay. So these are the possible types of failures, or this is the strength of the bolted joint. So here we have calculated the tensile strength, here we have calculated the shear strength. So here the tensile strength can be calculated by using this formula, P is equal to sigma T into A. So with this you can find out the tensile strength. Here by using this formula you can calculate the shear strength. Okay.